In this video, we're going to talk about section 9.5, which is solving radical equations. So when you are solving an equation, remember you're trying to figure out what value or values of the variable make the equation into a true statement. So when you think about the equation x plus 6 equals 10, what value or values of x make it true? And you would be right. It was b when x equals 4. So we do this, we can think of it similarly when you are dealing with radical situation. Thinking about the square root of x plus 6 equaling 10, what value or values of x make that true? Well, square root of what gives you 10? That's right, it's the square root of 100. So x plus 6 has to equal 100, right? Because that under the radical has to be 100. So what is your value of x such that when you add 6 to it you get 100? Well, that is x equals 94. But just this idea of thinking logically about the problem, it's not going to get you through your problems all very simply. So we're going to use what is called the power rule for solving radical equations. So the idea is that if two things are equal, x equals y, then you can raise both sides of the equation to a power of n. X to the n equals y to the n for any exponent n. Okay? So if we come back to this problem, we can raise both sides of our equation to the power of 2. It's not very good 2, this other one here. And then the square root, when I square it, will disappear. So I have x plus 6 equals 100. And then, of course, just like expected, you can solve this and get x equals 94. And so the idea is the square of a square root just gives you back your value of a. So square root of a, when I square it, gives me just back a. And that's actually true for any power. So if I take the cube root of a, when I raise it to the third power, it gives me back a, and so on and so forth with other higher powers as well. So let's see if we can't solve some of these. If I have the square root of 2x minus 5 equals 3, I'm going to raise both sides to the power of 2. Okay, so then 2x minus 5 should equal 9. And we're going to solve just like we would on any other linear equation. So 2x equals 14 and x equals 7. You can check this by plugging it back into your original equation. Square root of 2 times 7 minus 5, does that equal 3? Well, this becomes the square root of 14 minus 5, which is the square root of 9, which is indeed 3. Now, you cannot raise to a power of 2 until your square root is by itself. So first thing I need to do here is move this 7 because it's keeping my radical from being by itself. So now I'm going to have the square root of x minus 5 equals negative 4. And now we're going to raise both sides to the power of 2. So I get x minus 5 equals 16. And when I solve, I get x equals 21. Again, I want to check my answer. Okay, and what I see is, does the square root of 21 minus 5 plus 7, does that equal 3? Well, this is the square root of 16 plus 7, does that equal 3? What's the square root of 16? That's 4. 4 plus 7 does not equal 3. Oops. So this is what we call extraneous. Okay? So if you check a solution and it doesn't work, it's called extraneous. Remember, we learned that back when we were dealing with our rational equations. So 4 steps to solving these radical equations. Okay. Step 1 is, if necessary, you need to arrange the terms so that one radical is isolated on one side of the equation. Then you raise both sides to the nth power to eliminate the nth root or the nth radical. And then you solve. And you may have to repeat steps 1 and 2, depending on the type of problem. We'll see one like that. And then always check your solutions into your original equations. Okay? So remember, those extraneous solutions are solutions that arise, but they don't actually work in your original equation. So that's why number 4 is super important. Okay? And so we said, just like I was saying back earlier, that the nth root of a, if you raise it to the nth power, you get back a. So let's solve this one. Okay? So we're going to subtract 5. Because we need to isolate our radical. That was the first thing that it said. So we have the cube root of 2x plus 9. That equals negative 5. We're going to raise both sides to the third power. Okay, so I get 2x plus 9 equals negative 125. And then we're just going to solve. 2x equals negative 134. And x equals negative, let's see, 134, so that's 50, 65, 67. Okay. So now what I need to do is I need to plug that back in to check. Okay. So does the cube root of 2 times negative 67 plus 9 and then plus 5 equal 0? That's the question. Well, this gives me the cube root of negative 134 plus 9 plus 5. So that's the cube root of negative 125 plus 5, which is, of course, negative 5 plus 5. So that checks off just fine. So sometimes you will have problems here where you have an x, but it's keeping this radical from being by itself, so we're going to move it to the other side. So I have the square root of 8x plus 24, and that equals x plus 3. I write it as x plus 3. It's pretty typical to write the x part first. So we're going to square it. Think about what this means to square this side, okay? So this gives me 8x plus 24 here. And what I have here is x squared plus 6x plus 9. Don't forget this is x plus 3 times x plus 3. Okay? So I can see that this is a quadratic that I need to set equal to 0 before I can solve. That should be a 24. Okay? So I have 0 equals x squared minus 2x, and then this is going to give me a minus 15. So I need to factor. 2 factors that equal negative 15 when I multiply them, but add to negative 2. So that's x minus 5, x plus 3. X minus 5 equals 0, so x equals 5. X plus 3 equals 0, so x equals negative 3. When you check, you do need to check both of your solutions. So, square root, when I plug in 8 times 5 plus 24 minus 5, does that equal 3? Well, square root of 40 plus 24 minus 5. So square root of 64 minus 5 becomes 8 minus 5, which equals 3. No problem. Similarly, the square root of 8 times negative 3 plus 24 minus a negative 3. Does that equal 3? Well, this becomes the square root of negative 24 plus 24. Interesting. Plus 3 equals 3. So the square root of 0 plus 3 equals 3, and that checks off. So both of those are the solutions. On this next one, remember that to the 1/4 power actually means the 4th root of 2x plus 9. So I'm going to raise this to the 4th power in order to eliminate my 4th root. So I get 2x plus 9 equals 2 to the 4th power, which is 16. So I have 2x equaling 7. And x equals 7/2. Don't forget, we have to check. So 2 times 7/2 plus 9 to the 1/4 power, does that equal 2? Well, 7 plus 9 to the 1/4 power. So this becomes the 4th root of 16, and that equals 2. So we're good to go there. Okay, so that's all we've got on this one for now. We'll see you in the next video.